Okay, today we're going to be talking about something called combinations and permutations. And essentially, a combination or a permutation is nothing more than the study of how many ways you can arrange a certain number of objects, or more specifically, how many ways. Let's say I have 6 students and I need to choose 3 of those students to do a job for me after school. Then how many ways could I take 3 students out of a group of 6? Those are the type of questions that we're going to ask. So we're going to start off with a real basic example here. Example 1, in how many ways can 3 distinguishable objects be arranged in order? So let's just say we have the letters that spell the word cat. And we want to figure out how many ways could we arrange those letters. Well, I want you to think of it like, well, I'll tell you what, let's just go this route first. One scenario would be if the C is first, then the A is second, the T is third. Or the C is first and T A. This is not very difficult. Then the A could be first and the T and then the C. Or the A could be first and the C and then the T. Or the T could be first and then the C and then the A. Or the T could be first and then the A, then the C. So we count them up, 1, 2, 3, 4, 5, 6. Now that's pretty easy if you only have 3 letters. But if you say, well, how many ways or how many words, if you will, if we're not counting them as real words, could we arrange the letters that are in the word dictionary? Well, we wouldn't want to make a list like this, so we want to find an easier way of doing that. So this is what I'm going to call the box method. All right, so we're going to draw 3 boxes, and we're going to think of this like a Scrabble game. So let's say you have these 3 tiles, CAT, in a little pouch. You put your hand into the pouch, and the first question you want to ask is, how many possible letters could be the first letter of this word? Well, there's 3 possible letters. All right. Now you've taken 1 tile out of the bag, so there's 2 letters left. So when you reach in again, there's 2 possibilities for the second letter. And then now you've removed 2 tiles, and so there should only be 1 tile left. And if you multiply those together, you get 6. By the way, this is called a factorial. All right, there's a button on the calculator for that. So anytime you take a number and you multiply it times all the numbers that came before it, that's called a factorial. So for instance, 5 factorial would be 5 times 4 times 3 times 2 times 1. And that is a factorial. So those are the type of things that we are going to learn about in this video. All right, so in this second example, we see that there's a Tennessee license plate, and the license plate consists of 3 letters of the alphabet followed by 3 digits, 0 through 9. Find the number of different license plates that could be formed if, scenario 1, there's no restriction on the letters or digits that can be used. In other words, you can repeat them. So let's go ahead and draw 6 boxes. So it's 3, 4, 5, and 6. Okay, so these first 3 boxes must be letters and they can be repeated. So therefore, we want to say, okay, well, how many possible letters could be here? Well, 26. Okay, if you can repeat them, then there's 26 possible letters for the second space and 26 for the third. Now, these 3 must be digits, and your first inclination may be to use 9, but you have to remember it's 0 through 9, so you have to count 0. That's going to be 10 digits. So 10 possible digits here, 10 possible digits here, 10 possible digits here. And just like we did with the cat example, we're going to multiply these together, and we end up getting 17 million, and you're going to be surprised at how big some of these values are. 17,576,000 different license plates that you could make. All right, now if no digit or letter can be repeated, then that is a different scenario. Then it's going to be 26 times, now 1 letter is already gone, so you only have 25 more options. And now 2 letters are gone and 24. And then you have 10 digits But now you cannot reuse one of them, so you only have 9, and now you cannot reuse 2 of them, so you only have 8. And so that's going to make the number smaller. So that's going to be 11,232,000 different license plates. And so that is the answer for that one. All right, and this third example is very similar to the very first example, except we have more letters. So we want to figure out how many different 9-letter words, and once again, don't worry whether they're actual words in the dictionary, how many different arrangements maybe would be a better way of looking at it, that can be formed using the letters in each word. So there's 9 letters in dragonfly, and so once again, we could make 9 boxes and say, oh, well, there's 9 possibilities for the first letter. You use one letter, there's 8 possibilities in the second, and then 7, then 6, and 5, 4, 3, 2, 1. Or we could remember what we just said, which is when you take a number and you multiply it by all the numbers that came before it, that is called a factorial. So therefore, there's going to be 9 factorial different words that you could make with the letters in dragonfly. And that ends up being the number 362,880. So that's the answer to the first part of this problem. All right, now we have butterfly. Now notice there's still 9 letters, but we see that there are 2 T's in the word butterfly. And so let's just take, for sake of argument, let's just say that we took the T from position 3 and moved it to position 4. Then we took the T from position 4 and moved it to position 3. The question is, do we really want to count those as 2 different words? They still spell the word butterfly. No, we don't. So because of that, that means we need to realize that for every single word in this 362,880 different words that we could make with butterfly, half of them are going to be repeated words because the T's can be swapped and it still spells the same word. So once again, what we want to do here is we want to say, okay, there are 9 factorial different types of words you could make, arrangements of butterfly, but we want to divide that by 2 factorial. And once again, there are 2 T's, so you want to divide by 2 factorial. If there were 4 T's, you would divide by 4 factorial. So essentially, we want to take our answer to part A and divide it by 2, and that ends up giving us 181,440. And so there is the answer for part B. All right, now part C is the same deal. We have 9 letters, so we're going to start by saying, well, there are 9 factorial different ways that you could arrange the letters in the word bumblebee. But we have, looks like we have 3 B's, 1, 2, 3, and we also have 3 E's. So we have a couple of letters that are being repeated. So what we want to do is we want to say, I'm going to divide by 3 factorial for the B's, and I'm going to divide by 3 factorial for the E's. Now, there's a couple things I want to make sure you know that you can and cannot do with these factorials. 3 factorial times 3 factorial is not 9 factorial. It doesn't work like that. Let's think about that. That doesn't make any sense because then you'd have 9 factorial over 9 factorial, and anything over itself is 1. That means there's only 1 word you could spell with bumblebee? No, I don't think so. So you have to work these out separately. Now, you could either use your calculator and divide this out. If you do, please make sure you put these factorials in parentheses so that both of the factorials are on the bottom. If not, you may get a different answer. Or you could just realize that this is 3, 2, 1. That's 6. This is 3 times 2 times 1. That's 6. 6 times 6 is 36. So 9 factorial over 36 ends up being 10,080. And you can see that when you have a lot of letters that are being repeated, then there are a lot less words you can make. Okay, now we are going to start talking about what's called a permutation. And let me explain what a permutation is. A permutation is simply you're counting how many ways you could take a certain number of objects out of a group of a bigger group of objects. Okay, so N, let's just kind of talk about what these things mean. N is the bigger group. It is the number of objects that you have to choose from. And R is the number of objects you are removing from that group. So this is a smaller subgroup that you're taking out of a bigger group. And so this is the equation for that. NPR equals n factorial over n minus r factorial. So let's just say that I have 6 students in my room and I have 4 different unique jobs for them. So let's just say I have a filer. Somebody's got to file for me. An eraser, you got to erase the board, vacuum, and grader. And I have 6 students that I need, 6 students that will offer to do this, but I can only choose 4 of them. The question is, how many different ways could I choose those 4 students from 6? And that way we're going to use a permutation. So n factorial, n is the bigger number, so that's going to be 6 factorial over 6 minus 4 factorial. So that's going to give me 6 factorial over 2 factorial. And then I'm going to write 6 factorial as 6 times 5 times 4 times 3. Now, I could write 2 times 1, but I'm going to write that as 2 factorial. And that way, I can do something nifty here. I can cancel out the 2 factorials, and then I'm simply left with 6 times 5, which is 30, times 4, which is 120, times 3, which is 360. So 360 is the number of the number of ways that I could select 4 students out of a group of 6. Now, if you're typing this in your calculator, if you have a TI 84, then you're going to want to do 6 NPR 4. If you have an Inspire, you're going to want to do NPR parentheses 6 comma 4, and you can check your work that way. Okay, let's quickly do part B. You have 11 possible options. You're going to choose 3 out of the 11. And so you're going to put 11 factorial over 11 minus 3 parentheses factorial. So that's going to be 11 factorial over 8 factorial. And that's going to be 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, which we're going to summarize as 8 factorial, divided by 8 factorial. And then the 8 factorials are going to cancel. And then that leaves us with 11 times 10 times 9, which is 990. And so 990 different ways that you could choose 3 out of a group of 11. Okay, example 5, it says 16 actors answer a casting call to try out for roles as dwarves in a production of Snow White and the Seven Dwarfs. In how many different ways can the director cast the 7 roles? So basically, we're back to the question. We've got 16 people who want the role, but the director must choose 7 out of that bigger group of 16 that want the role. And so therefore, this is going to be 16 NPR, so P, capital P, 7 is how you want to write it. Now, the question becomes, because we're getting ready to learn about something called combinations, and so let's just talk about when to use a permutation and when to use a combination. Use a permutation anytime that the order matters. So when the order matters, you use a permutation. So that would be problems like when there's a role assigned, when there's a name assigned, anytime there is hierarchy, or rank, or if it's a caste, or maybe any of those type of things, maybe a phone number because the order of the numbers matters. Any of those situations, you're going to use a permutation because the order matters. In other words, it's not just enough that you have the 7 actors that you've chosen. As soon as you switch one dwarf with another, so Sleepy becomes Grumpy, or Grumpy becomes Dopey, there's going to be a different cast that you have to consider. It's not just enough that you have the same 7 actors in the play. So that's going to be a permutation. But if order does not matter, in other words, if people are equal status, that's going to be a combination. We'll talk a little bit more about that. So 16, permutation 7, use your calculator, that's going to be 57,657,600. Wow, that's a lot of different casts that the director could make. So you can see that the numbers are going to get really big for some of these problems. All right, in example 6, they give us 3 different scenarios, and in each scenario we need to figure out whether there's a permutation that is involved or a combination. In other words, order matters or order does not matter. So I don't want you to solve these, but I do want you to just put permutation or combination for each one. And at this point I want you to pause the video and see if you can do this on your own. Once again, do not solve, but just identify which situation it is, and then see if you get it right. Okay, we have a president, a vice president, and a secretary, and they are chosen from a 25-member garden club. So, does the order matter? Is there a role? Is there a name? Is there rank? Is there a hierarchy? Absolutely. So it's not just enough that you got the 3 people, you got 3 different roles. So this is going to be a permutation. It's going to be a permutation. And if we were to solve it, then it would just simply be 25p3. Okay, letter B. A cook chooses 5 potatoes from a bag of 12 potatoes to make a potato salad. All right, now I know this is kind of funny, but it's going to be a combination because think about it. The order of the potatoes does not matter. If you put potato 1 into the mixing bowl before potato 5, well, they're all 5 going in. There's no difference. They're all equal potatoes. So that's going to be a combination. Order does not matter. These 2 are pretty basic. Now letter C, you may get confused on. A teacher makes a seating chart for 22 students in a class with 30 desks. Well, as soon as you change one student and you switch them with the student sitting next to them, that's a different seating chart. So that's going to end up being a permutation. And essentially, that's going to be the biggest decision that you may have to make for most of these problems. Is it a permutation or a combination? Okay, example 7. In the Miss America pageant, 51 contestants must be narrowed down to 10 finalists who will compete on national television. Letter A, explain why we would use combinations here instead of permutations. Well, let's think about it. You have 51 women that want to be Miss America, and they are going to select 10 finalists. Now, each finalist has an equal chance to be Miss America. There is no numbering, there's no rank. They're not going to number the finalists 1 through 10. Finalist 10 does not have a disadvantage as compared to finalist 1 in winning the pageant. It's just that you all are the top 10 best contestants. So this is going to be a combination, equal status. Now, in how many possible ways can the 10 finalists be selected? Well, that's going to be 51 combination 10. So that's going to be 51 choosing 10, and that's how we normally describe this letter C, 51 choosing 10. And that is going to end up giving us, if we use our calculator, 12 billion, let's write it down here, 12,777,711,870. Wow, that is a huge number. And that just goes to show you that there's a lot of different combinations and ways that some of these objects can be arranged. Okay, example 8 says the Georgia Lotto requires winners to pick 6 integers between 1 and 46. The order, so here it is, the order in which you select them doesn't matter. So let's go ahead and make sure that that is clear. The order does not matter. So we know when it says that, we need to use a combination. So that is going to be, out of 46 numbers, choosing 6 of those numbers. And when we use our calculator, we will get the number 9,366,819 different lottery tickets. Okay, in this last example, we have Armando's Pizzeria offers patrons any combination of up to 10 different toppings. And reading these toppings is making me hungry right now. How many different pizzas can be ordered if, scenario A, you can choose any 3 toppings? In other words, you must choose 3 toppings, no less, no more. You have to choose 3. So the question is this a combination or a permutation? Well, let's just think about this for a second. Is a pepperoni, sausage, and bacon pizza different than a bacon, sausage, and pepperoni pizza? No, it's not. They're all going to be tasting the same. So this is not, we don't want to count these as 2 different pizzas. So therefore, this is going to be a combination. So if it's going to be any 3 toppings, then this is simply going to be 10C3. Out of 10 toppings, we're choosing 3, and that's going to end up giving us 120 different pizzas, 3-topping pizzas that Armando could offer. And then letter B is a little bit more complex. Now we're saying, let's say that we can choose any number of toppings. So in other words, a customer could come in and maybe they don't want any toppings, or maybe they want 3, or maybe a customer wants 5 or 10. So the question is, how many total different pizzas could Armando create for his customers? Well, let's just think about this for a second. How many pizzas could Armando make with 0 toppings? Well, that's just going to be 1. That's going to be a cheese pizza. 1 unique pizza with 0 toppings. Now, how many different pizzas could he make that have 1 topping on it? Well, that's going to be 10, right? A pepperoni pizza, a mushroom pizza, or a sausage pizza, so that's 10. Now the question is, how many different ways could Armando create a 2-topping pizza? So now we're asking a question, how many ways could a customer choose 2 toppings out of a possible 10? So that's going to be 10C2, and then 10C3, and then 10C4, and then how many ways could they choose 5 out of 10? And then how many ways could they choose 6, and 7, and 8, and try to see if we can write this smaller, 9, and 10. All right, but now if you use our calculator, we're going to notice a pattern. This is going to be 1, 10, 45, 120, 210, 252, and something really cool happens. The numbers start going back down. 210, 120, 45, 10, and 1. Now let's ask ourselves the question, why do the numbers go back down? Well, let's think about this. How many different pizzas could Armando make with all 10 toppings on them? Just 1, right? And that's the same way that it is with how many pizzas can he make with no toppings on it, okay? So how about, why is this number the same? Well, let's think about it. In this example over here, we were asking how many ways could we put 1 topping on the pizza. Here we're asking the question, how many different ways could we leave 1 topping off the pizza? So it's still going to be the same number. And when you add these together, you're going to get 1,024. All right, and that is one of the ways to do this problem, but I'm going to show you an easier way now. All right, let's look at this a little differently than we did the first time. Let's say we have these toppings. We have pepperoni, we have mushroom, we have sausage, we have onion, we have green peppers, we have bacon, we have prosciutto, which is ham, we have black olives, we have green olives, and we have anchovies. Okay, When we come to the choice of pepperoni, we actually have two choices. This goes back to the very first thing that we talked about in this video with the cat example. Well, we have two choices. Yes, I want the pepperoni, or no, I do not want the pepperoni. So there's two choices in that box. Now we move over to mushrooms. Yes, I want the pepperoni. No, I don't. There's just two choices. And then yes or no for sausage, yes or no for olives, or onions rather. Yes or no, 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 yes or no. So if we multiply those together, just like we did with the cat example and the dragonfly example and different things, you end up getting, actually the license plate example, 2 to the 10th power, and that is 1,024, which is the same answer that we got with the combinations and adding them all together.